called, we're going to do a couple things today, but the first one is what is often referred to as the second fundamental theorem of calculus. You don't have to know that it's called the second fundamental theorem, but the gist of it is derivatives undo integrals. And we have already talked about this several times. There's just going to be a little bit of a hitch in this problem like this one right over here. And what I mean by that is, up to this point, if I gave you an example and I said, if you were taking the derivative from a to x of f of t dt, you all know that that is just f of x. So when you think about, like, if I said, okay, what's the derivative from 2 to x of the sine of t dt, hopefully you would be like, oh, that's just the sine of x. And you'd be absolutely right. And that's a perfect explanation for that one. Now, but what if I gave you an example and I said, okay, let's take this same one, but let's make the integral from 2 to x squared of the sine of t dt. So it can't be the same thing. I mean, if it was the same thing, then that wouldn't make any sense, because this one's x squared and this one's x, and that wouldn't make any sense if these were the exact same answer. But so what the answer to this one is the sine of x squared times 2x. Now that comes from the chain rule. We did integrate the sine, and then we put in the bounds, and then we differentiate it, and we'd have to do the chain rule when we put in the x squared. So that's why there's an x squared in there. The reason that the 2 goes away is we would end up differentiating a constant. I mean, so think about it this way. If I did this in its steps, so let's say I said, okay, I did this, I said, okay, well, the integral of sine is negative cosine of t evaluated from 2 to x squared. And then I plugged in that and I said, okay, that means I have negative cosine x squared minus negative cosine of 2. So I'd have this. And now I have to differentiate it. And the derivative of cosine is negative sine, so this becomes sine x squared. But then we have to differentiate x squared, which is 2x. Now we also have to differentiate cosine 2, which is 0. So our answer is just sine x squared times 2x. And that's what I said it would be, right? I mean, that's what I said it would be. You don't have to do all those steps. You can just skip right to the answer, because you know that they're going to undo each other. You know that they're going to undo each other. So take this one right here on the side that's listed. You got, one more thought on this. If I asked you to, my last example before I do this problem on here is if I asked you to differentiate the integral, let's say it was x squared to 2 of the sine of t dt, hopefully you kind of go, oh, well, that can't be the same thing as the one we just did, because now we've switched the bounds. But hopefully some of you are kind of going, but I know what it would be. It would just be negative sine of x squared times 2x. And the negative would come because we're going to subtract the bounds. We're going to do the top bound minus the lower bound, and that's where the negative would come in there. And we would have the negative from that subtraction. So hopefully those 3 examples are all really you need. You need to know, okay, that's one example, 4 examples, I guess. So here's the first one. You need to know that one, how that works. So here's another example, a practical example with variables in it. Here's what happens when the one of the bounds is not just x. It's something that can be differentiated into more than just one. And then here's the one, well, what if we switch the bounds? Because that will cover everything you have. So if you take this one that's been on the page for a while, and I said, go ahead and differentiate this. And I said 2 to 4x cosine t squared dt. Hopefully you kind of go, I could do this. This is going to be the cosine of 4x squared times 4, because we have to differentiate the 4x. And that would be the answer. If I show you the solution over here, it gets here, and they went through and simplified it and made it 16 because you can square that 4 in there, and they put that 4 up in front. But it's the same thing. Really easy problem, but it's really awful if you've never done that before. So hopefully that makes sense. A couple other things that you're going to have. So these problems, I want you to do your best on these, remembering that it's important to note the steps, right? It's important to note that you got position, velocity, and acceleration. So differentiate to go up. Integrate to go down. So when this one says, okay, you got this particle moving along the x-axis, the position is x of t, the velocity is v of t, and the acceleration is a of t. And it says, what is the average acceleration? So the average acceleration is, you could think of that, well, that's the slope of velocity. So if you're going to do out of these 3 things, that's this one, right? I mean, to get acceleration from velocity, you just differentiate it, and that's what you have. You got the slope, and it kind of goes in and tells you, what it is, average value, and kind of goes through some other comments on it. So do your best on those, but the step diagram is going to be a huge piece of that one. Now, the next thing you're going to have to do is you're going to do some calculator work. Okay, so I'm going to show you how to do. You could always do integrals off of a calculator. So let's take this one. It's saying, okay, the velocity at 0 is equal to 1, and the acceleration is equal to t to the 0.3 sine 3t plus 5. And it's saying find v of 3. So here's what you have to do. Know that v of some new value is equal to v of some given value plus the integral from the given value to the new value of the acceleration. That's how you can find any velocity of a new one. What did it start as, and what was the change in velocity? So when we're asked to do this problem that's listed right here, v of 3 equals 1 plus the integral from 0 to 3 of a of t dt. Well, we can do that on our calculator. On your TI Nspire, if you go to the TI Nspire, and I'm pulling mine out here so I can make sure I get the keystrokes right, turn it on, make sure it's in radians, make sure your calculator's in radian mode, okay? And then what I want you to do is you're going to hit menu. You're going to go down to option 4, which is calculus. So you go down to option 4, and you're going to do number 2, which is numerical integral. And if you click that, what will happen is you will get this, where all you have to do is fill in the blanks. Now, before you do this, I would always do this in terms of x. Before you do this, you do 1 plus. And then you would go through and put in all the things that you'd have. So like if I was doing this, I would do, let me go on here. If you hit doc 7 2, that'll get you to be able to do, and then hit enter a bunch of times to get the calculator to think it's in terms of radians. But if we do this one and we go from 0 to 3, and my A of t is, I'll use x to the, I know you can't see what I'm doing, but I'm just typing it into my calculator, and I'd encourage you to do that too so you can practice it on a specific one. Sine 3x plus 5, and then you got to put dx in there, and then I'm going to put the plus 1 on the back side of it just to get it in there. And what you'll get is in this case, is equal to 1.9962. And if you need help with your calculator, let me know, but I'm going to have you guys kind of do this and just come back and let me know if you need help with your calculator. To the nearest thousandths, 1.996, and so I don't know what they're doing on this. The nearest thousandths, hundreds, thousandths. Oh, I should have. I don't know what they're doing on that, but I thought I'm right on that, but whatever. So if you get it wrong on Delta Math, don't worry too much. But I got the same answer as they did. So do your best and let me know if you have any questions. I'm going to spend a minute here closing this stupid thing out. So if you're wondering, why does he take so long to close it out?